Good evening, everybody. Today we will talk about how to make a symbolic representation for a function. How to represent a function by using symbols. As we studied in the previous lecture, we said that a function means that each element in X, which is called the domain, has only one image, not more, not less, only one image in the set of Y, which is called the codomain. Moreover, we said that the set of images or the used items in Y is called the range of the function, which is always subset from the codomain. So take care of this point. The range is always subset from the codomain. So when I say f is a function from x to itself, it will be not from x to y like here, it will be from x to x. It's called the function on x. Here you should take care that x is the domain and also the codomain. So the range will be subset from x, not from y, because by the way, I don't have the set y. Let's see how to deal with functions. In this example, he is telling me that x equals -1, 0, and 1, y equals 0, -1, -2, and the function f is a function from x to y. Then x is called the domain, y is called the codomain. F of x, the function of x, equals x power 2 minus 1. Find the set of the function and represented by the arrow diagram. Let's see together. F of x equals x squared minus 1. To find the output, I will find f of -1, I will find f of 0, I will find f of 1. Each one of them, for example, f of -1 means that I'm asking you to replace each x in this form by -1. So I will substitute instead of x, I will put -1. It will be 0, which is -1, 0. F of 0 means to substitute or to replace each x in the function above and put instead of it the value 0. So it will be 0 squared minus 1, which is -1. F of 1, so I will put instead of x 1. So it will be 1 squared minus 1, which is 0. So it will be 1, 0. So when I'm writing the set of the function, the function f will be equals -1, 0, and 0, -1, 1, 0. If you are asking me to find its range, the range is the set of output. These numbers are the range. So it will be 0 and -1. 0 is repeated 2 times, but I can't repeat the numbers inside a set. The last part is to represent by using the arrow diagram. I will put here x, and in front of it I will put y. X has -1, 0, 1, and y has 0, -1, -2. -1 got 0, and 0 got -1, 1 got 0. So it's the function and how to represent it. Let's see one more example. X equals 2, 4, 6, and 8. Y equals 1, 2, 3, 4, 5, 6. And it's a function. F is a function from x to y. So as we said before, x is called the domain, y is called the codomain. The range here will be a subset from the set y or the set of the codomain. Let's see what the function say. The function is saying that f of x equals half x, 1 over 2 x. So I will get f of 2, f of 4, f of 6, f of 8. Again, what does it mean? To find f of 2 means that in this function I need to replace each letter x with the value 2. So I will need to find half 2 in instead of half x, it will be half 2, which is 1. So I have to move the pair to 1 1. And instead of x, I will put 4. So I need half 4, which is equals 2. Hold the pair 4 and 2. And instead of x, I will put 6. So I need half 6, which is half 6, which is 3. So 6 and 3. Half 8. Instead of half x to 4. So 8 and 4. This is the set of the function. I got it. Represent it on the Cartesian diagram. I will put here x and I will put here y. X, because you said to me it's a function from x to y. Then on the horizontal axis I will use x, which is 2, 4, 6 and 8. On the vertical axis I will use y, which is 1, 2, 3, 4, 5 and 6. 2 is used with 1, 4 is used with 2, 6 is used with 3, and the last one, 8, is used with 4. Find the range. The range is the set of outcomes, the set of arguments. All these numbers, 1 and 2 and 3. This is the range. So again, let's read it together. When I'm telling you f of x, it means a function of the variable x. So to find f of 1, I'm asking you to replace or to substitute each letter x by the number 1. Let's see the next part. The next part is talking especially about something which is called the polynomial function. What is the meaning of the word polynomial function? The polynomial function is a function whose rule is a term or an algebraic expression that should have two conditions. Algebraic expression with two conditions. The first one, each of the domain and the domain should be removed. Depending on this point, the first one should be for the set, which is the dimension. And the second one also should be. Here I'm asking, do I mean that x is a set of numbers? This means that I need all the set of numbers? No. I'm telling you that x, which is the domain, and y, which is the most favorite or the most famous codomain, they should be a subset from the set of numbers or the whole set. This is the first condition. The second condition is the power, and sometimes it's called the power index of the variable x should be a natural number. When I say to you a natural number of the power, you should understand that I have no square root or cubic root of x, no roots, no negative powers, no fractional powers, and no fraction with x in its denominator. So we can say we have a lot of examples for the polynomial functions. 2x plus 5 is an example for the polynomial function. Also, k of x equals 8. So you'll ask me, the pair 8 has no x. So what about the constant functions? It has like a fixed price, a fixed value. It's always will get 8. When I ask you find the k of x, substitute each x and put 1, it will be 8. K of 0 8. K of 3 8. Here it's called a constant polynomial function. So don't be afraid when you see it. G of x equals x squared minus 2x plus 1, or n of x equals 1 plus square root 2x minus 9x to the power 2. Hey mister, I would like to ask you a question. You told me no square root or cube root, and here you say to me that square root 2x is a polynomial function. How come I said to you no square root or cube root, only the variable x? Here, the square root in this example only on the number 2. So what about the square root 2? It's a constant value. So it doesn't matter for me. The issue here, the power of the variable x is a natural number. X of 3 is a natural number 3. X first degree or has power 1, so it's a natural number. 1 is from the 0 degree or absolute choice, so it's also a natural. Okay, is it clear or not? Okay, let's move to the next part. What about finding the degree of the polynomial function? What is the meaning of the degree? The degree is the highest power of the variable, but take care, the highest power of the variable in the function after simplifying. So you should simplify first. Don't forget this point, which is very critical. Don't forget this point. You should simplify your function, then after simplifying your function, find the highest power to be its degree. For example, if I have 3x minus half, x here has no power, so it's power 1. It's a linear function for first degree. Square root 5x squared minus 3x plus 2, the highest power here is 2, so it's second degree, or sometimes it's called quadratic function. F of x equal x power 3 minus 5x power 2 plus 4. X power 3 is the highest power, so it's called third degree function or cubic root function. Very important. Note the constant function A is a constant number, belongs to the set of real numbers, whatever it is, whatever, positive or negative, but don't use it. So I can say that A belongs to R star. What is the meaning of R star? R star means all the set of real numbers except the number 0. Because if you have f of x equals 0, it has no degree. When you want to determine the degree of function, which is a very important point, as we say, you should simplify before telling us. Let's solve some examples and see how to deal with it. The function f of x equals x squared multiplied by x, 2 plus x whole squared. Take care of this statement. You have x squared and bracket with x also squared. So it will be x squared multiplied by x squared. You know from the previous years that x squared multiplied x squared, on multiplying the same variable, we add the powers. So it will be x to the power of 4. So it will be 4. In this example, x power 2 minus x minus 5 to the power 2. If you reduce this, it will be x power 2 minus x power 2 plus x minus 25. X squared cancels x squared. So the highest power here will be xn, which is first degree or let's simplify the next example. X power 4 minus, let's perform this multiplication operation. X squared plus 1 multiplied by x squared minus 1 equal to x power 4 and plus 1. x4 minus x4, the result will be 1, which is absolute choice, so it's 0 degree. The next example needs from me to find f of negative 3. As we said before, to find f of negative 3, you are going to replace each x and put instead of it the number negative 3. So it will be negative 3 to the power 2 minus negative 3 minus 2. And calculate. It's 9 plus 3 because negative multiplied by negative will be positive minus 2. So it will be 12 minus 2. The answer is 10. The last one is finding f of 0. F of 0 means replace each x and put instead of it the number 0. So it will be 0 to the power 2 minus 2 multiplied by 0 plus 5, which is equal to 5. Let's see more examples. X multiplied by x power 3 minus 2. What is its degree? X multiplied x power 3 will be x power 4, so x fourth degree. F of x equals 3 minus 5x, find f of negative 2. To find f of negative 2, replace each x and negative 2. So it will be 3 minus 5 multiplied by negative 2. The answer will be 30. F of x equals x power 2 plus x minus 1. Find f of 1 plus f of negative 1. So I will put f of 1, I will replace each letter of x and put in 1. So it will be 1 power 2 plus 1 minus 1. This is f of 1 plus f of negative 1, negative 1 power 2 plus negative 1 minus 1. So 1 minus 1 and here 1 minus 1. It will be 1 power 2 minus 1. The answer will be 0. So let's move to the next one. F of x equals 4x plus k and f of 2 equals 15. F of 2 equals 15 means that if you replace each letter x with 2, the answer will be 15. So it will be 4 multiplied by 2, which is 8. 8 plus k equals 15. After the equal with an opposite sign, so k will be 15 minus 8, which is 7. Let's move to the next one. Here, he is telling me that f of x equals 2x minus 1. Prove that f of 2 minus 3f of 1 equals 0. Let's find f of 2. I will replace each letter of x with the number 2. So it will be 2 multiplied by 2 minus 1, which equals 3. And f of 1 equals 2 multiplied by 1 equals 1. So to find f of 2, I will put the values, which is 3 minus 0, and here we get the required two proofs. Another example, the function f is from R to R, the set of real numbers, the whole set of real numbers. Okay, f of x equals ax squared plus bx plus 5, a is equal to 0. So when you say to me a is equal to 0, then the function should be bx plus 5, because 0 multiplied by x squared, it will be 0. Then the degree of function first degree. Why it's a first degree? The x power 2 multiplied by 0, so it will be cancelled. Find b if you know that f of 3 equals 11. That is the meaning of f of 3 equals 11. This means that I will replace each x and put instead of it the value of 3 to find the f. So it will be 3b instead of x plus 5 equals 11. I will subtract 5 from both sides. Equals 6. 4, 5 will divide by 3 for both sides to get equals 2. Another example, he is telling me that f is the function of x equal 3, 4, 5, 6. Okay. F of 3 equal 3, f of 4 equal 5, f of 5 equal 5, f of 6 equal 5. Write the set of the function. I will write it 3 with 3, f of 3 equal 3, f of 4 equal 5, f of 5 equal 5, f of 6 equal 5. And mention its range. The range is the set of outcomes 3, 5, 5, 5, 5, 5, 5. So I count it in 5, it will be 1, 5. And representing on the R diagram, I will put x here and x here. No y, because it is telling me that it's a function on x. 3 with 3, the 4 with 5, 5 is 5, and 6 is 5. The next question. X equals 0, 1, 3, y equals 1, 2, 3, 4, 5, 7. And the function for x to y where f of x equals 5 times 6. Find the range. To find the range, I should find f of 0, f of 1, and f of 3. Let's do it. F of 0 means 5 minus 0, which is 5. F of 1, 5 minus 1, which is 4. F of 3, 4 minus 3, which is 2. Then the remaining will be 5, 4, 2. To represent it on the Cartesian diagram, I will put x here and y here. X on the horizontal axis, y on the vertical axis. I will put 0, 1, and 3, and on y 1, 2, 3, 4, 5, and 7. Let's put our point 0 is 5, and 1 with 4, 3 with 2. Here we got 3 angles, 3 points. If you need to write the set of the function, I will Great. Third lesson in Unit 1 of Judo. I hope that you will get it well, you will understand everything here. I wish you good luck in all the coming, but please don't forget to solve these problems with yourself and solve extra questions. I wish you good luck. To see you in the next videos.